Hello everyone, welcome back to my channel Infinity Minds, where maths is made easy. Today we shall be doing chapter number 4 of Ganita Manjari, exploring algebraic identities. Okay, so let us begin. Okay students, so what is an algebraic identity after all? Coming from the word name of the topic, algebraic identity, it is not something which is new. Class 8 students have done this. In class 8 you do some part of it. We shall first be revising in fact what you've learned in class 8, and very similar, it is the same thing but few more identities added to the set. Okay, so let us see. An algebraic identity is an equation that is true for all values of the variables occurring in it. Now see students, we've just done equation solving in fact in before also. X plus 3 equals to 5. So it's x plus 3 was an expression, in fact it is equal to something. It will be true for only a particular value of the variable. Okay, it is true for only a particular value. But on the contrary, identity is something which is true for any value of the variable. As a synonym, in other words, students do call it like a formula. Yes, at the end of it, in a non-mathematical words, you can call it a formula. Like if you're going by, the actual name is identity. But yes, in children we do call it formula also at times in easy words which students can relate to, that it is true in every case. But a formula involving where it is variables, so you have your identity that for any value of the variable it would be true. Like if I put x equals to 10, then also it is true, and so on. All this is you remember the identity, we've done this in class 8, a plus b whole square. Okay, an equation is true only for a specific value of the variable, but an identity is universally true for any value. Okay, we will be revising further more by doing questions. Then the first identity that you study in class 8, a plus b whole square. This is the visualization of it. Many of you must have done an activity also based on this. So there is a square of side A and there is a square of side B. If you join it and you wish to get a square of side, this is A and this would be B. And this will also be A and B. So a square of side A plus B. A plus B is one side, A plus B is another side. Area of a square is side into side. So a plus b into a plus b is your a plus b whole square. Visually also you can see it is equal to the sum of squares of the individual terms, a square, b square, and product of the terms ab, twice ab, 2 times product. Okay, visually that is what it holds. And mathematically solving wise, as an identity, it is square of the first term, square of the second term, plus twice the product of the two terms. The terms inside the bracket is like your expression. Okay, it's a binomial expression containing two terms. You can say those terms can be variables, constants, like that. Okay, so we'll next. A minus b whole square was also there. It is very much a square and b square, but the 2ab becomes minus 2ab. Watch that the plus b is getting replaced by minus b. It is actually plus b getting replaced by minus b. We can easily prove by replacing the b with the minus b in identity 1. It is only another way to look at identity number 1. That you are adding the minus of b, nothing else. That is what is being shown. And there was another third identity also that you had studied, a square minus b square, which is equal to a minus b into a plus b. Okay, that can also be applied. Let us see. Let us begin with the exercise. First two exercises are mainly, in fact, first 2-3 exercises of Ganita Manjari are all kind of your revision, you can say. They are all last year based. But yes, the level of calculation is going higher at times. But that is, you will be absolutely comfortable, I believe. Using the identity, so it is being told in the question. Don't expect it will always be told. Maybe it says solve using any one of the identities and you are expected to know the identity. A plus b whole square. So it is written also. A square plus b square plus 2ab. You need to learn, practice writing your identities. I shall be sharing the chart of identities with you at the end of the chapter. Once we also learn the new identities that we are supposed to learn in class 9. Okay. So here A takes the value 7x, B takes the value, it is like the first term is 7x and the second term is 4y. More than learning A and B, I would emphasize my students to learn squaring the first term and squaring of the second term. Square the first term, square the second term. 7 square will be 49, x will become x square, 16, y square. Twice the product. 2 into 7 into 4 and x into y. Okay, this would become your answer. Next, 7 by 5x plus 7 by 5x plus 3 by 2xy. So square of the first term, 7 by 5x square you will do, plus 3 by 2y square you will do, twice of 7 by 5x into 3 by 2y. Try and see how we will be doing this. So the 2 shall cancel with the 2, and in case anything else could have cancelled, 7 into 7 49, 5 into 5 25, x will become x square. 3 into 3 9, 2 into 2 4. Yes, we can rearrange, like I am in a habit of writing a square and b square terms first, and as per the case the plus 2ab or the minus 2ab term can be placed. Okay, most of the books and children also write, yes, plus 2ab and then the b square term. That is the standard way to write. This is also equally valid. 2ab shall become 7 into 3 21 upon 5xy. All this is there in front of you. Now a and b getting replaced by decimal numbers. Square of 2.5 is 6.25. Remember square root, children. 25 square is 625, and single place of decimal in the square shall become two places of decimal. Okay, 15 will be 225, that's a 2.5. These are unlike terms. Some students still feel confused. Even reaching class 9 doesn't change the situation. It's a p square, q square and pq. Unlike terms, you don't have to do anything, and the answer will remain as it is. Okay, we are not going to further do anything about it. Clear? Let's go to the next. Another one to practice. 3 by 4 s plus 8t square. So square of 3 by 4, 3 3s are 9, 4 4s are 16, 8 8s are 64. 2 into a into b you can do, and the answer shall of course contain s and t. 4 2s are 8, 2 2s are 4, 3s are 12, st. Okay. I hope you try them out before looking at the solution. In fact, you try them out, you will find them easier. X plus, this is the level I was talking about, that little application will come. Slightly more, like in class 8 they were absolutely straightforward, but now yes, you could expect a decimal or fraction. So it's an x plus 1 by 2y. Okay, x plus 1 by 2y. Try it out, children, try it out. The 2xy term shall become like this. You can see the answer in the slide later. It will be an x by y. And similarly, 1 by x plus 1 by whole square. I don't think so much of explanation is needed. It's a very simple ones. Good ones for you to practice. Using the same identity, yes. Now, identities are applied to numbers also, okay? Select 64. If I am breaking it up as 60 plus 4, then 60 shall play the role of A and 4 can play the role of B. Using the same identity, supposedly it is said use any identity of your choice. Tell me what else could we have used? What else? Just for example, I could have framed it like this also. It won't be wrong. Then I will be making use of A minus B whole square. Okay. That is equally if you are given a choice. Or it's not which is better. This way, this question, either ways it's the same. Ideally, questions of this type are the ones where identity application is valid. This is just given for practice. Like instead of finding 105 square, you are making use of 100. If you get a number like this, so that your calculations are done verbally. 100 square is at 10,000 plus 2 into 100. See how much verbal it is. 5 into 2, 10 and 25. 10,000, so that's an 11,025. None of them you actually need to calculate in the rough column. No, you can just verbally solve them, these calculations. 205, 200 plus 5, the square of 200, square of 5 and twice of 2 into 200. I don't think it will be a problem. Okay, 40,000 plus 2,000 plus 25. Next, yes, I've taken this up as per the order in the book, but the exercise doesn't have, seems to be. I'll be sharing extra questions with you. So, factorization. X squared plus 7x plus 12. You remember factorization? No, maybe some students have not done factorization. As per the NCERT new syllabus, factorization is not in class 8, or some of the students. In the old syllabus, it used to be there. Anyways, we will just see. Let us start fresh as if you're doing for the first time. So, I will be teaching you the tricks how to do them. You are basically to find two expressions whose product will come out to be this. Okay, how to go about it? When we'll solve questions, I'll share you all the possible ways. It's very simple and interesting. As of, let's have a look at the diagram shared, which similar one is shared in Ganita Prakash. So there is first of all, it's not a square. Can you notice that? It's a rectangular tile of one side x plus 3 and the other side x plus 4. Like this is your x plus 4 and that is your x plus 3. So what do? You have learned multiplication of expressions, haven't you? Like x shall multiply with the entire x plus 4. If you are asked normally to solve this, that is what you would do naturally, x square plus 4x. Remember, number outside the bracket multiplies with everything inside. 3 into x, 3x plus 12. Here, this is what I was talking about. Now, if they are like terms, we shall add them. Nobody will tell us separately, but the ones we were doing earlier, they were three separate terms. A square, B square, 2AB, they were unlike terms. So, but yes, it is your moral duty to look around in the answer. If the terms are like, they need to be put together without anyone separately telling you that club them together. Yes, they are to be clubbed together. So the point is that you were given this and used to multiply and get this used to be your answer. But now this shall become your question. Okay, and you have to work reverse. We have to go reverse. Okay, I shall be sharing with the tricks with you how to go reverse also. But for the time being, I don't want to make it confusing for you. If it's a rectangular tile of side x plus 3 and x plus 4, how are they describing? That you put a square tile of side x. If this is x and this is 3 units, they are calling. Okay. This is also x, but this is 4 units they are calling. So what about this? This is 3, this is x. So the area for this tile becomes 3x. If this is 3, this will also come out to be 3. If this is 4, this will come out to be 4. That's why this is 12. This will be 4 into x. 4x, x square, 3x, 4x, 12x, 12, 3x and 4x, 7x. So diagrammatically that has been explained. Okay. So we come to the second exercise. It says factor completely. I feel the word factorization should have been written, but the book says factor completely. Basically, find the factors. This is same or the reverse of the 4.1 that you have done. You were given a plus b whole square, children. You were given this and you were finding this. Isn't it? You were finding. Now the reverse. Answer is given. You have to move back to the question. We will see how. 9x square is nothing else but it is the square of 3x. Those are called whole squares. Okay, those are called whole squares. 16y square is the square of 4y. With repetitive practice, you will be able to analyze the pattern that you have to look, and you are expected to think around, okay, this is a square value. Yes, this is a square. So the middle one should come out to be the product. Okay, should come out to be the product of 2AB form. twice into 3x into once you get the a square and b square, then create your 2ab. Many students start creating. This should be created right at the end. First get your a square terms clear and then make it 2ab. So this is nothing else but the a plus b whole square. A square, b square and 2ab, the answer that I am having, that means this must be the square of this. 4s square, square of 2s, 25t square. As you look at the question, you must glance through that where are my square terms, and in between I shall split it up as 2ab. Okay, like just by looking, those who are smart with practice, it will become 2s and this is plus 5t. Okay, whole square of that. But you must have the steps. You know, almost these steps can be skipped. They are to be done in the beginning. Once you are used to, you are absolutely fine if you go ahead with this. That we are expressing 4s as square of 2s, 25t as square of 5t. This is 2ab and hence this. You need to write that. Otherwise, who is allowing you to write this? Because of the identity. Because of this identity allows me to write. So I must mention my identity. I must mention. You getting? I'm writing so that you remember. Clear? Next. As I told you, repeat it once to practice. 49 square of 7, 4 square of 2. These are still very, very simple, straightforward. When you get fractions and all, yes, maybe a little bit you are required to do it. 64 is clearly, it's like one has to think of the square roots, children. So 64 would be the square of 8, naturally p. 4 by 9. See individually, this will be 2, this will be 3. So it should be a 2 by 3 whose square that we look at. Middle term is not something you really need to think. It has to come from this. Get your a square and b square correct and your 2ab should get formed. 2ab will not be a problem. First write your 2, then write your a, that is 8p, and then write your 2 by 3q. If anything gets cancelled, but it doesn't. So it will be a 2 into 2, 4 into 8, 32 by 3 PQ. Yes, you have to write that. That is correct. That's what we were wanting. You have to cross check, children. You have to cross check. And then it is a plus b whole square. Now see, 3a square plus 4ab plus 4 by 3b square. Okay. Not so obvious, but taking 3 common. Then you get the identity. A square can only be the square of A. AB is the term which is the middle term. So we don't have to think. We have to concentrate on this. 4 and 9. So 2 by 3 B. Now if these are the two, they will help you to get the middle term. 2 A, 2 by 3 B. Let me just cross check. 2 into 2, 4 by 3 AB. Yes. Yeah. So A will come and 2 by 3 2 by 3 B will come. So sorry for the break in between. A plus 2 by 3 B will come for these two. Remember 3 was already outside. A will come from here. 2 by 3 will come. 2 by 3 B will come from here. This will be the whole square like this. You first have to take common. Okay. This hint is sort of given in your textbook in the questions, okay? But just don't expect it when you have your test. In general, I'm saying, okay, hints won't be given. With practice, you will understand. You have to make sure, if you're told factorize, you have to think whose squares are these. If not, then let me see if there is anything coming common. First think of, just take common, and if not, then think of whose squares value it is, which identity can be applied. Now, if you just straight away look, it doesn't look like. Okay, it doesn't look like. So, taking 1 by 5 common, This is an important fact. Okay, taking 1 by 5 common, 9s square. Now it's not easy to take 1 by 5 common from 6. Okay, it's not easy to take 1 by 5 common from 6 and from 5 also. Let's see how we get it. If you want to take 1 by 5 common, see, it is like your 9 into 1 by 5 that you have. Anything that goes out. So your 1 by 5 is going out. So you are left with 9. You wish to have 1 by 5 outside. No. It's like you wish to have a 1 by 5 outside. So I must write this thing. How can I get a 6 if I want to take 1 by 5 common from it? If I replace it by 30, 5 into 6. 30 divided by 5 will only give me 6. That you should be able to think of. Taking 1 by 5 is 6 into 5, 30. And similarly, taking 1 by 5 common from this. 1 by 5, what do I put here that I get a 5? You want to get a 5, you want to take 1 by 5. If I replace it by 25, it will be 5 5s are 25. 5 can be written as 1/5 of 25. This step you could have put extra here. And then then you are taking 1 by 5 common, so you are left with 9s square plus 30sv plus 25b square. This would be 3s plus 5v whole square. 1 by 5, 3s plus 5v whole square, mention the identity. Okay. Find the value. Let's do question number 2 now. Find the values of the following using the identity. The second one, children, a minus b whole square. Now apply it to numbers, but they have given the subtraction. It can be vice versa. 79 is most suitable to be written as 80 minus 1. So students, you can write it as anything. Anything as in, you could also write it as 100 minus. But that will be more problematic. I mean, in the sense, if you write 100, it has to be a 21. So, but if you do it, it's not wrong. 100 is an easy number. The 1021 square you will be dealing with. It's one's choice. But if the identity is mentioned, then don't do that 70 plus 9. Okay, addition. 80 square plus 1 square, because somebody would say 1 is a simple number. Yes, even I feel that, in the sense 80 square can always be done. 6400. And this becomes faster. And 21 won't be that. The idea is what is easy. A square, b square minus 2ab. Now see, notice here we are not writing the identity because it is already mentioned by the question. If not, then one has to write. Clear? 193. Nearest whole number, nearest round off if you do, would be 200. Okay, accordingly one has to see. The nearest power of 10 you could say, nearest, if you would have rounded off 79, you would have got 80. So its distance from that number is what we check. So 193 closest round off would be a 200, and then let us express it as 200 minus 7. Okay, don't do all those errors. Some students missed. Okay, this is a square minus b square. This is completely a different identity. When 193 has a square, so this is also something students do know. It is 200 minus 7 is one number 193. That one number has to be squared, students. One number has to be squared. That these are very small things which children don't realize. For them everything is same. They would even write this and expect, and they would perform the rest of the steps correctly. Do whole square, write only 7 square. This is square of 7. This is square of both. We have to do squaring of the bracket. Okay. Be clear of these small errors which you may make, or which you may have been doing in the past, but no more now, class 9 onwards. Okay, so that goes for square of the first term, square of the second minus twice the product. I hope nobody needs explanation for this. Sign of the number is before. This is positive. Two positive integers minus the negative like sign number signs should be added first, and then 2800 should be subtracted, preferably. 299 would be 300 minus 1, very same, a square b square minus 2ab. Our second exercise come to an end. Please subscribe to my channel, like and subscribe, and keep watching Infinity Mind for more videos. Thank you everyone.